Hey guys, today we're going to talk about Chapter 9, 2, Addition and Subtraction Identities. Woo!
Okay, so our input, when we talk about the f of x, the object of the preposition of, which is our x, is called the argument. Okay, so when we say sine of 7 pi over 6, this is what, in mathematic terms, that is called the argument. Okay, it's important that you know terminology so when we refer to it later, you understand what we're talking about. Okay, so sometimes we have an argument that can be represented as a sum or a difference of two other angles. Well, every angle actually can be represented as a sum or difference of two other angles, but we are actually interested in when we have an angle we need to work with and we don't really recognize it, but maybe we can break it down into two angles on the unit circle, and then that lets us actually find the sine of the angle. Now, we know that the sine of 7 pi over 6 is negative 1/2. You should know that without even thinking. And let's break down 7 pi over 6. One way to break down 7 pi over 6 is pi plus pi over 6. Now, some of you have tried to do this little technique, and that is wrong. Because if we, sine, this is a function. It is not a coefficient to be distributed across the parentheses. If you tried to do the distribution across parentheses, then you would get sine of pi plus sine of pi over 6, and you know that the sine of pi is 0, and the sine of pi over 6 is 1/2, and 1/2 plus 0, which is 1/2, is not equal to what we know to be the sine of 7 pi over 6. So this is a very important bit of information you need to know and do not forget. A function does not distribute across its argument. Okay? So, we actually have some nifty little formulas, and you're going to look at these going, oh my gosh, I have to memorize these. Yes, you do have to memorize them, but there's some patterns that are easy to recognize. If we take the sine of two angles, say angle A and angle B, one way that we have, an identity that we have that lets us break down this angle that's in the argument is to break that angle into two separate parts, okay? And you take the sine of the first one, sine of A, times cosine of B, plus cosine of A times sine of B. Now, if we have sine of A minus B, we're going to look at how that all works out in a minute. Sine of A minus B, that would be sine of A times cosine of B minus cosine of A times the sine of B. Notice that each one of these terms has a sine and a cosine, and it's the different angles. And also notice that whatever sign you have in here is the sign you have here. Okay? When we move to cosine, we have cosine of A plus B. It's the cosine of A times the cosine of B minus the sine of A times the sine of B. Notice that in the cosine angle addition identity, you have both of the cosines in the first term, both of the sines in the second term, and C for change the sign. Okay, that's not a mathematical reference, it's just a stupid way to remember. Think of cosine, you got a plus in here, we're going to change the sign, it's going to be a minus right there. Okay, also our last identity, cosine of A minus B, again, the first term is your product of your cosines, the second term is your product of your sines, and you again change the sign. If you have a minus in here, there's a plus in here. Now what I can tell you is there's a lot of theory that goes into this, but it would totally make this about an hour-long video, so we're not going to do that. But let's go back to that way that we worked with sine of 7 pi over 6. Okay? From the two angles that we used, sine of pi. Now this is not a situation where you should need to use it, but let's show you how we can do it. The two angles that we chose were sine of pi plus pi over 6. So according to our addition formula for sine, our addition formula for sine takes the sine and cosine of each angle and the same SIGN that's in the parentheses. So we're going to do sine A and cosine of the other angle plus cosine of A, sine of the other angle, and we're going to evaluate. Sine of pi is 0. Doesn't really matter what cosine is at this point. However, on any quiz and or test, you have to put what cosine is, or else we'll count off because we want to know that you do know the value. Cosine of pi over 6 is square root of 3 over 2. Plus cosine of pi is -1. Please put a parentheses whenever you encounter a negative. Times sine of pi over 6 is 1/2. So let's look what happens here. Now you can result that to 0, and this is -1/2. So our final answer is -1/2. Now again, we knew that without doing this work, but we're going to work with some more complicated problems where this technique would be used.
All right, so here's an example of a situation where we would need to use this because sine of, let's see, 12, there we go, 17 pi over 12 is not on the unit circle, but I wonder if I could break it into two things that are in the unit circle. In fact, I wonder if I could break it into things that would take that denominator and reduce it to things with 3 and 4 in them, because I know all of the 1/3 and 1/4. In fact, I could almost do it with 6 and 2.
You could do it with 6 and 2, but we'll do it with this pair, and we're going to do it with 6 and we're going to do it with I don't know, something else later.
Okay, so let's think about this. 17 pi can be broken down into, okay, let's see, 9 and 8, and 9 is divisible by 3, so let's...
So if I have a 9 over 12, that's going to become 3/4,
Mm-hmm.
and 8 over 12 is going to become 2/3.
Yeah.
Okay, so I'm going to make this one
8 pi
and make this 9 pi. Notice? Now guys, how do I know which one to do? You know, you just have to play with it.
If I pick 1/12, it's not reducible. If I pick 2/12, that reduces to 1/6. The leftover stuff would be 10/12.
If you pick 2/12, you need to do 15/12, and
which
let's
reduces
see, by 3, so that would be 5 pi over 4. And you could use that pair.
This is a pair that you could use. We just decided to use 3 and 4, okay? You could use 6s and, you could use 2 and 15.
So we are going to break down 17 pi over 12. We are going to work this as a sum, and this is the pair we're going to choose to work, okay? So that's what we're going to do. We're going to work this one in a sum and use that. Now here's the technique of what you want to show. Yeah, I'm gonna
make it smaller so we can keep it, but not.
Well, we're doing this on the next page, the cosine one.
I just want to give us. I know that.
Yeah. And I gave you extra room on your notes because some of you told me, I hate it when I don't have enough room. So I did that on all of the notes that you'll be getting for the next several sections. Okay, the first thing that we want to do, the way to learn a formula, is you write the formula down first. Sine of A plus B is
sine of A plus cosine of B plus cosine of A times the sine of B.
Okay, that's the first thing we do. Next thing is we're going to show our substitution. It doesn't matter if you put the 2 pi over 3 or the 3 pi over 4. It does not matter. What matters is you do the right thing with it. And then we're going to show the work. Sine of 2 pi over 3 times
cosine of 3 pi over 4 plus the cosine of 2 pi over 3 times the sine of 3 pi over 4.
Okay, now if you don't know your unit circle, that is a shame. If you have to draw the unit circle to do this, that is a shame. At this point, you should be able to tell where these things are. 2 pi over 3 is here, and that is the point, -1/2, and square root of 3 over 2. So 2 pi over 3, the sign is square root of 3 over 2. 3 pi over 4, again, that's a reference angle of 4. I'm at pi over 4, so it's square root of 2 over 2, but that one's negative. Square root of 2 over 2. Cosine is parentheses, negative square root of 2 over 2. Once again, notice how we like that in parentheses, right?
Especially since we're multiplying.
Yeah. Cosine of 2 pi over 3, parentheses, -1/2. Sine of square root of 3 pi over 4, square root of 2 over 2. And now we're going to do our work. So notice, when you multiply two radicals, you can multiply what's under the radical and keep the radical. So that's square root of 6 over, multiply the denominators, and in front is a negative. And then minus, The 1 times square root of 2 is just plain old square root of 2 over 4. This is ugly, but it's going to get a little bit uglier even. We're going to write it all over one denominator. Notice that this negative here has to go with the term. If you want to put a negative out in front of the entire fraction, you have to write this as square root of 6 plus square root of 2 over 4. If that negative comes out in front of the fraction, this is the way your answer is. Will we accept this answer here? Sure. But if you bring that negative sign out in front, then you need to make sure you have the right math.
Okay.
Okay, so we're going to do cosine of 5 pi over 12. Do you want to try this pair of angles just for grins?
Well, this is 5
Oh,
pi
5
over
pi.
12.
No, we can't. Oh, forget that. Okay, so we're going to go do 5 pi over 12. We're going to go through the same process. Okay? So here we have 5 pi over 12. And we're going to, again, look for, well, I like to do sum whenever possible because it helps reduce a negative sign error. But we can look at 12 if we do a plus, something and something, we can do that. Another possibility, let's for grins also look at a minus. Okay? So if we did a plus,
Well, if we did a plus, we could do 2 and 3, because 2 and 3 reduce nicely.
yeah, 2 pi, which would give us pi over 6, and 3 pi would give us pi over 4. That's nice. What if we do a subtraction one?
Well, we could do,
Let's see, what if we do 9 minus 4? 9 pi over 12 minus 4 pi over 12?
okay.
Would that work?
Yeah.
9 minus 4? And that would give us what? 3 pi over 4 minus pi over 3. Okay?
I really like the first one better.
Yeah, I mean, this one's okay, but, you know, again, in general, I try to stay away from the subtractions if possible, just because that's one more place for me to make a mistake.
And
you know.
subtraction ones will always make one of your fractions bigger.
And this one, the coolest thing about this one is both of the angles are in quadrant 1.
Mm-hmm.
And so you know that sine and cosine are both positive in quadrant 1, so you're not going to have a negative sign error. Whereas here, this one's in quadrant 2, so you have to pay attention to where cosine is negative. It's not impossible to do it, but you know, you learn how to make smarter choices. Do you want to reduce that? Or is that good enough?
I think it's
good enough, huh?
that's good.
So we are going to do cosine of which we
First
went,
one.
okay.
Pi over 6 times the plus the cosine of pi over 4 equals.
Okay, so first we're going to write what we're going to put in. That is very important. We want to see how you've decided to break this down, okay? All right, that's the first thing. Now we write out the formula. Go ahead.
Cosine of pi over 6 times the cosine of pi over 4 minus
C for change the sign.
the sine of pi over 6 times the sine of pi over 4.
Okay.
Well, the cosine
Change
of pi
the
over
sign.
6.
Remember, since we're dealing with our cosine, we're going to let that represent change the sign. And back here, when we're dealing with sine, it's going to be the same sign. Okay. That is only a memory technique. It is not a mathematical technique.
All right.
Okay.
Cosine of pi over 6 is square root of 3 over 2 times square root of 2 over 2 minus 1/2 times the square root of 2 over 2. So that gives us square root of 6 over 4 minus the square root of 2 over 4, which equals the square root of 6 minus the square root of 2 over 4.
Now, let's talk about this for just a moment. Just to understand what we're dealing with, where is 5 pi over 12? I mean, it's not on our unit circle, but if we draw the unit circle, and we have this as a denominator of 12, then here, pi would be 12 pi over 12, right? So pi over 2 would be 6 pi over 12. So 5 pi over 12 should be in here somewhere, correct?
Yep.
Now, what do I know about an angle in quadrant 1? The cosine of 5 pi over 12, since that is in quadrant 1, should be positive. So now the question is, you're looking at that answer going, I don't know, how do I know if that's positive? Well, is it square root of 6 bigger than square root of 2.
Of course it is.
I mean, I don't know what the square root of 6 is, but square root of 2 is about 1.4, and square root of 6 has to be bigger than 1.4 because the square root of 4 is 2, and that's bigger than 1.4. So this is bigger than 2. Square root of 6 is bigger than square root of 2, so that number is positive. So we have a positive over 4, which is a positive value, which means we are okay.
Yeah.
Okay? All right.
So now go to section 9.2 and work numbers 2 and 4. No calculators, please.
This looks kind of scary. There's some properties we're not covering that are listed in this section. We've actually referred to them before called cofunction properties. This one's going to do something a little bit kind of neat, but I thought it would represent just how to do what is really going on when we do these. So let's not be afraid. Let's let this be our A. Let's let this be our B. So writing the formula out, this would be cosine of A times cosine of B.
Change
the sign plus sine of A, sine of B. Okay, well cosine of x, well we don't know what x is, so that's cosine of x, times cosine of pi over 2.
Cosine
0.
0, yeah.
Ah, pi over 2, come over here, that's the only angle we know. Pi over 2 is the point 0, 1, so our cosine is 0. Plus sine of x, and sine of pi over 2 is 1.
So we get the sine of x.
Now, where is that useful? Do you remember that the cosine of, I don't know, 25 degrees would equal what? What's the complement of 25?
Complement of 25 is 60. Yeah, 65.
Okay, so is it true that the sine of 65 is equal to
The cosine of 25
minus 90?
90.
Cosine of 25 minus 90 is cosine of negative 65, but cosine's an even function, so the cosine of 65 so that would equal the cosine of, oh, this should be 65. Sorry. This would be 65 minus 90, which is the cosine of negative 25. And cosine is an even function, so the cosine of negative 25 is cosine of 25. So all of that does work. It's just kind of a neat thing to remind you that the co in cosine means it's a complementary function of the complementary angle. Okay, don't forget that. That's useful down the road.
Okay, so now we're going to prove that 2 cosine A sine B equals sine A plus B. Well, the nasty part is on the left-hand side, so we're going to...
The right-hand side.
Right-hand side, I'm sorry, I'm dyslexic with my hands. I've always been...
She also doesn't feel well either. Yeah, she's...
Anyway, so we've got the sine of A plus B is the sine of A times the cosine of B plus the cosine of A times the sine of B. That's the first part. Then we're going to subtract the sine of A minus B, which is the sine of A times the cosine of B plus, minus the sine of A, or cosine of A times the sine of B. All right.
We need
Now
to
we need
distribute
to
that
distribute
negative.
the negative, so we have everything all nice and pretty. Sine of A, cosine of B, plus the cosine of A, sine of B, minus the sine of A, cosine of B, plus the cosine of A, sine of B.
Sine of B.
Okay, now notice, it gets kind of confusing with all these letters here, but if you can pick out the ones that are the same, you've got a sine of A, cosine of B, minus the sine of A, cosine of B, so those cancel out. And you have cosine of A, sine of B, plus cosine of A, sine of B. So, so those two will combine, and 1 plus 1 equals 2. So you get 2 cosine of A, sine of B. Which is what we were asked to prove in the first place. So on the other side, we will write what we were asked to prove.
So don't let these frighten you. Okay, now these are 2 more identities. They're for tangent. Okay, You can memorize them. Tangent of A plus B is tangent A plus tangent B over 1 minus tangent A tangent B. Notice that this sign is the same. This one, tangent A minus B, is tangent A minus tangent B over 1 plus tangent A tangent B. Now, here's the thing that's really cool. Isn't tangent A equal to sine of A plus B over cosine of A plus B? So, to be honest with you, in my opinion, you really don't have to memorize these if you actually can remember how to do this. So, we are going to do this, okay? So, the tangent of A plus B can be written as the sine of A plus B over the cosine of A plus B. Well, let's write out what the sine of A plus B is. It's sine A cosine B plus cosine A sine B. I like to write my functions where the first angle is the one that I list first, sine A, and the second one is the one I do second. That way I'm sure that I'm doing things in the right order. Now the next one, the denominator, cosine of A plus B, is cosine A, cosine B. C for change the sign, minus sine A, sine B. Now, you might look at that and go, how in the world does that become that? So we're going to divide all terms by cosine A, cosine B. So here we go. Sine A, cosine B plus cosine A, sine B over cosine A, cosine B minus sine A, sine B. And now every single term is getting divided by cosine A, cosine B. So here's what's awful cool, right?
All right, so the first one, the cosines cancel each other out, and that ends up with sine A cosine A, which is the same thing as tangent of A, plus the cosine A's cancel out, and that gives us tangent of B. The bottom, both cosines cross out, so that gives us 1.
0, right? 0?
No.
0?
2 divided by 2 is 1 minus, well, we've got sine A over cosine A, which is tangent of A, and sine B over cosine B, which is tangent of B. And there's where the equation comes from. Boom.
Right? So the trick is you're going to divide through by cosine A, cosine B. And you can do the same thing with the second function. So again, this one you can always generate in case you forget it. But it does require you to know the sum and difference identities for sine and cosine.
Yeah.
So those 4 you have to memorize. Okay, this is a really, really cool idea because here we want to find the exact value. Whenever you see that word, what does that mean?
Exact value?
No.
No decimals and no calculator, because you can find the actual thing with square roots.
Yeah, or you may know you might have some Pythagorean triples, or you may actually know the angle on the circle.
Mm-hmm.
So we're going to find cosine of A plus B and tangent of A plus B. But look what we're told. We're told A is between pi over 2 and pi. That means A is in quadrant 2. Now that would be a good thing to know because in quadrant 2, cosine's negative, sine's positive. B, meanwhile, is in quadrant 1. Well, that makes that nice because every single function has a positive value there. But notice that you're not told anything about what the angle actually is. You are told the cosine is negative 4/5 and the sine is 5/13. Now, does that work?
I want to draw a triangle.
I know the Pythagorean triples. So if we look at A, we know A is in 2. we can draw a triangle, but you should know our ratio here is that the cosine of angle A is -4/5. So first of all, being in quadrant 2, it works out. We do have a negative value. We don't know the exact lengths of the sides, but we know the ratio of the sides is -4 to 5. So we could say, well, if we let x be -4 and we let r be 5, then what does y have to be?
3.
It's a Pythagorean triple, and we're in quadrant 2, and y
Let's
is
draw the
positive.
triangle.
Okay. If we draw the triangle,
It's in
y
quadrant
is 2, here's y 3, x is -4, and our triangle going to the point there looks like this. Boom. See it?
Yay!
And there's our point. X is -4 and y is 3. X is not the cosine. Remember, cosine can't be -4. That's bigger or smaller than -1 by a lot. But our ratio of the x side and the radius side is -4/5. Now, let's talk about angle B. We know angle B is in quadrant 1. Now, that's kind of cool. And we have that the sine of angle B is 5/13. Now, in quadrant 1, all of our x and y's are positive, so that's kind of cool. Once again, we don't know that the length of the y coordinate is 5, but we know that if we let y be 5 and we let r be 13, then x in this scenario has to be 12. And so we're looking at 5 for y, 12 for 13.
12 for x.
12 for 13, yeah. 12 for x, we mean. Sorry, so this is 12/5. Okay, so we have that. And now we're ready because now we have, look, our cosine is given to us. We're going to need that. Our sine is given to that. But we're going to need for A, the sine of A. So what is the sine of angle A?
3/5.
With the information given to us, sine over A is 3/5. We have sine of B. We're going to need cosine of B. What is the cosine of B?
Cosine of B is, let's see, 12/13.
Okay, so now we have everything we need, and here we go. We are going to, first of all, find the cosine of A plus B. Once again, always write out the formula first. Cosine A, cosine B. C stands for change the sign. A, sine B. Okay, and now we're going to go substitute all of those values that we have found. Cosine A is -4/5. Once again, if that is not in parentheses, we will kill you. All right, cosine of B is 12/13. We found that from the work that we did. Okay, minus sine of A is, we found that, 3/5. And sine of B was given to us, 5/13. Right? Okay, here's the deal. The denominator is 65. This is a pretty, oopsie, not 64 though. This is a pretty common denominator, you'll see, because there's just only so many Pythagorean triples you can use that make the problem easy, guys. All right, and that's going to give us a negative, what, 48?
48 minus 15 over 65.
Common denominator, so that's 48 plus 15 is what, 63?
Yeah.
That is our cosine of A plus B.
One thing we can always check is to see if that value is less than 1, like the magnitude is less than 1. Because if it's bigger than 1, then we mess something up.
Remember, cosine and sine always have to be bounded by 1 and -1.
And that was asking for the cosine. So.
Yep, and so now we're going to do tangent of A plus B. Well, I remember that by dividing everything through, this is going to give me tangent A on top plus tangent B, because in order to do this tangent identity, I would have to have sines on top, and sine on top keeps that sign the same. And then on bottom, I'm going to have a subtraction sign. And remember that the first term all canceled out. So this is minus tan A times tan B. Okay? You've got to find your own way to memorize these, guys. And yes, you do have to pretty much memorize them. And here we go. Now, we haven't found tangent of these, so let's come back over here. Tangent of A is your y over your x. So what, -3/4?
Mm-hmm.
Okay, and let's come over here and write tangent of B, and that's going to be... It's useful if you write those out, guys, because when you're doing all this kind of work and you make a mistake, and if it's just a mistake of, at least you knew how to find the tangent, and then by the time you stuck it in, you left the negative sign off, you don't miss as many points as if you don't show us any work and we think you don't know how to do it. Okay,
Yep.
Tangent A, -3/4, plus tangent B, 5/12,
Parentheses.
over 1 minus, yeah, I could do parentheses there, 1 minus tan A, which is -3/4, times tan B, which is 5/12. Okay, now this problem, we've got to get common denominator. We have all kinds of yucky things happening, but do you remember back in the fall when we worked for and dealt with complex fractions, we said one way of working with this is to take the LCD and multiply both the numerator and the denominator by the LCD of all of the fractions. So look at all of the fractions in the problem. What is the lowest common denominator of all the fractions?
12.
It's not 48. 4 times 12, it's not 48.
But 12 has a 4 in it.
All of these denominators go into 12. They all go into 48, but 48 is going to give you bigger numbers, and
That's
eventually
fine.
you're going to have to reduce. So if we multiply the numerator and the denominator by 12, let's look what happens. By the way, the whole idea when we do this is all the fractions in the fraction should be gone. And here we go. 12 times -3/4 is negative.
9.
4
9.
goes into 12 3 times, -9. The
Plus
12 is cancel. Okay. Now
12.
bottom, 12 times 1 is 12, minus. Okay, now this is where it's kind of tricky. So we might want to recognize that that is -15 over 4 times 12.
Oopsies, we may have had to do 48.
Yeah, I think we did. So now we have a bigger problem. Boop. That doesn't work. We're going to now go back and do 48. So sometimes when you see this, you have to actually rethink your work. Okay? So the 12 didn't work because of this step right here. So we have now added a layer of how you need to think about problems like this. All right? So let's go back and redo this part here, and that won't take us very long. So now we're going to multiply by 48 over 48, because actually what you have here is -15 over 48. So we have 1 minus a -15 over 48 right there, and that was our clue that we needed to use 48. Okay? So here we go. Ready? Distribute, Ms. Miller.
Okay, 48 divided by 4 is 12, times 3 is 36. So -36 plus 48 divided by 12 is 4, times 5 is 20, over 48 minus.
And minus a minus, let's make that a plus,
15.
and then that's going to cancel. Okay?
All right, so -36 plus 20 is -16 over 63.
Okay? So be careful of this mistake right there. Okay? That is just going to be when you're dealing with tangent, because we have this product right here. That meant that our denominator actually became 48. Okay?
Okay. Oops. All right, so do number 37 in section 9.2.
Actually, I want to say one more thing about this problem. Because the last thing it says is, then determine which quadrant A plus B lies in. Okay? Let's look at what we have. We have the cosine of A plus B is negative, so that means from that information we're in quadrant 2 or quadrant 3. And we have the tangent of A plus B negative. That means A plus B is in quadrant 2 or quadrant 4. So where is our A plus B?
2.
Theta, which is equal to A plus B, our angle theta, which is equal to A plus B, is in quadrant 2. That is a really cool conclusion. Therefore, those 3 dots mean therefore. That is a really cool conclusion to this problem. Now, work that ET problem.
Then, confirm that you watched the video and do your email, por favor, para ti. Para nosotros.
Whatever. Do it. To both of us. Well, you know.
And don't email me, Mr.
Okay, we're bored. Bye. Love you.
Bye.